97% of the water on our planet is too salty for us to drink or use for watering crops. Of the fresh water on Earth, almost 70% of it is frozen. If you look at the drinkable liquid water on our planet, it turns out that most of it is underground. Groundwater is liquid water that fills up spaces in between rocks and soil particles. As it moves through the ground, it dissolves minerals and can form sinkholes and caves. Certain types of rock allow water to pass through them. They are permeable. Other types of rock don't allow water to pass through. These are called impermeable. Have you ever wondered why caves are common in some areas and rare in others? Or how deep someone needs to dig to create a well? I'm Science Mom.
And I'm Math Dad.
Today we're looking at water underground. Hello! A quick welcome to Amanda, Nathan, Margaret from Texas, Catherine, Joshua, and Samuel, also watching in Texas, Emily and Caleb in New York, and Jennifer, who said the word search was fun. I'm super glad to hear that. We'll be on page 92 to 93 of the notes today. And a welcome to Elena from Nebraska.
We say Claire from California, too.
And for those who are watching the replay, special welcome to you. And for our live students, oh my goodness, right as we were going to hit go live today, our computer rebooted and the screen went black. It was rather terrifying.
I guess it was better that that happened before we started than right after we started.
That's true. So we're a couple minutes late, and fingers crossed, I think it's time for this computer to go through some diagnostics and see what's going on, because that was rather terrifying. Are you ready to learn about groundwater?
Yeah, I don't know much about groundwater.
Let's start with a real simple demonstration. I have two sponges here. One of them is slightly green, and the other one looks yellow. And you might have guessed that this green one, which looks just a little bit darker, you can see a little bit of dripping there, it has some water. Just give me a guess, Math Dad, if I squeeze this out, how much water is going to come out of the sponge?
Okay, it's definitely less than the volume of the sponge right there.
You can see a little bit, I've already lost some in the pan here. You see this?
Oh, that was all in there before?
That was all in there before.
Okay, I don't know, half a cup.
Half a cup? Let's try it.
Ooh, squeeze, Science Mom. You can do it.
That's a lot of water that I just got out of this sponge. But maybe even more impressive is how much I can pick up again if I stick it in this. So I have exactly 1 cup or 8 ounces of water in here. Okay. And if I push the sponge in and squeeze it all down, try and get it all the way submerged in the water, I've squished it down into the water. And now if I slowly bring it up, I should be able to get just about all of the water out of the cup. Let's see how well I did.
All right.
Slowly bring it back up and...
Oh, you really did get most of it out.
Look at that. We have less than 1/4 of a cup left in there.
Nice.
Now, we don't think of rocks as being the same as sponges. Obviously, this is like soft and squishy, right? Tons of air in it. But soil and certain type of rocks, they do have air spaces in them. And when water sits on top of those rocks, certain rocks and certain types of soil, the water can percolate down in and you get groundwater.
Okay, so groundwater is like water inside a sponge, except the sponge is the rocks?
The sponge is a rock, yes. Groundwater is water that is underground. And most of the groundwater that we have on the continents, a lot of it is fresh water because it comes from rain. But not always. Let's open up our slides. We're going to do a real quick little slideshow for you guys with some fact or fiction, and I want to see what you know about groundwater already. But before we get into our pictures, I just want to point out something important for the word search. If you ordered one of our supply boxes, it might not say up here that all of the words except for one can be found below. And I don't want anyone to be super frustrated that there's one word that they can't find. So one of these words is not in the word search, but all of the others are.
So it's just a hint, but without telling you what it is to make it extra challenging. Yeah, there's a little accident somehow.
So Math Dad was really focused on sneaking in math words like algebra. And my theory is that's how it happened. So he was putting in math words and forgot to include one of the vocabulary words.
My theory is that Science Mom deleted it.
That could have happened too.
Yep.
We don't know. All right. But if you go down further in our word search, we have a little diagram where we show you how groundwater can get sometimes trapped in between layers. So let's zoom in a little bit and take a look right here. If you have rock that has air in it, so here we have a little bit of water here that I've kind of colored gray in the notes. And if there's water and air, then this is not fully saturated. That means all the spaces aren't filled with water.
Okay.
And if it's all the way saturated, then this is what we call the water table, the line between where we still have air and the line between and down here where it's all full of water. This is called the water table.
That dividing line.
That dividing line.
Okay, so that word saturated that you used, that means like maximally full?
Yes, completely full. So like the sponge when it was all like it is now. See how this sponge is just dripping water? It is saturated. And you see how Matt Dad was like, no, not over the computer.
No messes, Science Mom.
Now let's take a look at some of the things that happen when you have groundwater. So down here, B, this is our zone where we are completely saturated. And if there is a layer where the water can't get through, and we end up with this part here where the groundwater is trapped, if there's a little crack that comes up, that forms a spring.
Oh, so when water's coming out of the surface, say again, what's causing that?
It forms a spring. If there is groundwater that is trapped between two layers, pressure can build up, and then the water will come out of a crack or an area where it can get out. And I'm really curious, let us know in the chat if you have seen a spring before. Springs in the desert are kind of amazing because it will be completely dry, there are not many plants around, and then all of a sudden there will be a big pool of water flowing out of rock.
That seems pretty weird because why water should go downhill, right?
Well, the water is going downhill. So one of the springs that we visited recently here in Nevada, there are mountains by this spring, and the water, when it rains, goes into the ground underground. You can't see it, but it's there. And then it hits a layer where it's impermeable. It can't go any deeper, and it starts flowing slowly along, and it comes out at this crack where there's a spring.
So it's not like it's
cool.
Pushing it up like a geyser or shooting it up.
Sometimes that happens.
Gravity is actually causing it to be there. So it's at a low point typically? Typically. But sometimes you do get springs that have some pressure and they'll kind of bubble out of the ground if the part of the aquifer or groundwater is higher. So yeah, I'm seeing lots of people say they've seen springs. Jennifer, Maurice, Noah, Coaster Cody.
If you've never seen a spring before, start looking for them because there are a lot of them around and they can be a really important source of drinking water. Let's go back to our diagram now on page 92. So we have our lake up here and then all the water below the lake where it is porous.
So that means this is a rock layer?
This is a rock layer below the lake, but there's groundwater here. And then this spring right here, since it's below the level of the lake, the water kind of will flow out this way. That's one example of how you can get a spring. Lakes and rivers act kind of like windows into where the groundwater is. They show you where the groundwater is. All right, first fact or fiction. You ready for this, Math Dad?
I am so ready for this.
If you dig a hole deep enough, you will eventually find water. Is this true or false? And with this picture right here at the beach, of course, at the beach, if you're going to dig down, as soon as you get to sea level, there will be water in the sand.
Because so the water table is at sea level there.
It is. And the sand is very porous, just like a sponge. There are little holes of air in between all the grains, and water can move into that sand really easily.
Okay, but you're asking wherever you are, you'll always be able
to hit water.
Hit water if you dig deep.
Denali says true. Elizabeth says true. Kai says true.
Everybody's saying true. I was going to say false.
Coaster Cody says false.
Because, it just seems like there'd be some places where you're not going to hit water. So the crust is thick, but surely there's somewhere where you could just drill down and not hit water. I don't know. I'm going to say false because I just don't think so. But
so in my opinion, you will find people arguing about this online. In my opinion, the best answer to this is not quite.
Aha.
So the best answer is mostly false fiction because there are holes that have been drilled, especially for oil exploration in the desert, where you can drill down really, really deep, even a couple kilometers, and not hit water, depending on where you are. But most places in the world, if you drill down, you will in fact hit water eventually. And one of the deepest holes in the world actually ran into water deeper than they expected.
Oh.
And it wasn't groundwater. It was water that they think had actually formed from hydrogen and oxygen in the rocks that had then come together because of all the pressure.
Oh, wow. Hadn't even thought about that possibility.
Let's take a look real quick. This is a graphic from XKCD, a fabulous comic. And just to give you an idea of scale, the Mariana Trench, the deepest part of the ocean that we talked about last week, that's really deep. And I love that they've included this scale, because the Mariana Trench, although it's very deep, it's not deep like plunging straight down. That's actually to scale what it looks like.
Oh,
but
I was thought of as a crack in the ground, but you're saying it's pretty wide?
It is pretty wide.
Okay.
I mean, and same with Mauna Loa. You might think of Mauna Loa in the island of Hawaii as being super, super tall, and it is super tall, but it's a shield volcano, so the slope is pretty gentle.
Oh yeah, I totally picture those taller.
Now, because you're looking at this on a screen, Math Dad, and it's fairly small, do you think that the deepest hole we have dug as human beings, would that be deeper than or not as deep as the Mariana Trench?
We talked about this a little bit. That like in Russia, they were trying to dig all the way through the crust, if I remember right, and try to reach the mantle. And I think the Mariana Trench is a mile or two at the most below sea level, and I think they had dug deeper than that. So I believe we have dug deeper than the Mariana Trench.
And you are correct. Good memory, Math Dad. This is the Kula super borehole. It is incredibly deep, all the way even deeper than the Mariana Trench. And it turns out that boreholes, they're only about this big in diameter. They're made with a drill, but they can go super deep. And the Deep Horizon, the well that had a leak a while back off in the Gulf of Mexico, it was almost as deep. There are some boreholes that have even gone deeper. And quite a few of those are fairly dry. They don't run into much groundwater, but some of them do. It all depends on where you're at.
I would think there would be groundwater underneath the ocean for sure.
There it is. Yep, underneath the ocean, you're always going to have a layer of groundwater because of all that water sitting on top. But in certain parts of the desert and continents, you might have areas where there is not much groundwater at all. It all depends. Usually, you will run into groundwater, but not always. Another fact or fiction for you, Math Dad.
I'm ready.
Most groundwater is in the form of fast-flowing underground rivers. This is a picture of a waterfall in a cave in Nebraska. So there's a stream running through this cave. Is this the way that most of our groundwater is?
Okay.
In the introduction, we learned that almost 30% of our liquid water on Earth is underground. So my question now is most of that in underground rivers?
Okay, so certainly a river would have a big concentration of water, whereas in other layers, it would just be like a drop here and there maybe, so it'd be way spread out. But at the same time, there's probably a lot of places without rivers.
There are.
So I could argue this one both ways.
Eleanor says false. Harper says false.
Fact, fiction, false. False. Okay, I'm gonna go with the chat on this one. I'm gonna say that this is false.
Correct. Most groundwater is actually very slow moving. There are subterranean rivers and cave systems, but they are the exception rather than the rule. Most groundwater is very, very slow moving, and it's more like water inside a sponge, where if you had a really thick sponge, which was actually made out of rock and the cracks were super, super small, would you be able to pour water on that and have it just go gushing through?
Nope.
No, it has to go through slowly. So let's take a look at groundwater. This is similar to the graphic that is in the notes, but again, super important to realize it's spaces in between rocks. And if you have something like gravel or sand, there are a lot of spaces and they're all connected. If you have rock, sometimes they're just thin little cracks in the rock, and that is where the groundwater is. What is this line in between the unsaturated ground and the saturated ground?
Ooh, I remember this word. It was the water table.
The water table. And the water table, often you'll be able to see where it is if you look at lakes. Lakes and rivers often show you where the water table is. And if you just go straight out, then you can find the water table. And if you dig a hole down to the water table, you end up with a well. And wells are a really important source of drinking water. I want to know, Math Dad, before we go to our next question, if you had to guess, how much of the water in the United States comes from groundwater, the water that we use to drink and for crops? What would your guess be?
If it's not groundwater, it would be
surface water from lakes and rivers.
Just lakes and rivers. Okay. So in that case, I don't know. I'm just guessing half.
Half? So let's talk about Las Vegas real quick. We live in the desert, and right now, about 90% of the water that the city of Las Vegas uses comes from the Colorado River, and it comes from Lake Mead. There's a big reservoir right by where we live. But before the year 1970, almost all the water used in Las Vegas came from groundwater. In fact, that's why the city of Las Vegas exists where it does, because there was an aquifer. An aquifer just means a layer of underground water that was in the rock, and you could dig down about 100 feet, and then you would find water. So the city had all of these wells dug down to about 100 feet, but in the year 1970, we ran into a problem. The wells now, you had to dig down to 150 feet to get water. And the water level kept dropping and dropping because we were pulling more water out than was coming in.
That's not good.
So then the city switched over to using the water from the Colorado River. But back to our question, if you look at the country as a whole, the country of the United States, how much water comes from groundwater? Marine Man Quinn says 30%. I'm seeing quite a few different guesses in the chat. What is your guess, Math Dad?
50%, half of it.
It's about 39%.
Oh.
So quite a bit, not quite half. We get quite a bit from surface water too, but a decent amount.
Okay, I'm trying to picture what an aquifer is in my head. Is it different than if I view an underground lake?
If the underground lake can be filled with rock, then that's a good way to think of an aquifer. But it's all that water is in spaces in between grains of rock and sand. So if you dug down into an aquifer, it would be like digging a well where water would fill the well. But if you dug out sideways from the well, you'd be going through wet rock. It's not like an underground lake in that you could like sail a boat on it. You can't sail a boat on an aquifer, but you can dig out the dirt and the dirt is wet.
Gotcha.
Let's take a look real quick. I've got two maps I want to show you. We'll talk just a little bit more about groundwater before we talk about caves. So this is a map of aquifers in the United States. And one of the biggest is the Ogallala Aquifer. And I have to say it has one of the best names of any aquifer anywhere.
Ogallala?
Ogallala. The Ogallala
say that 10
Aquifer.
times fast. Go. Ogallala Aquifer, Ogallala Aquifer, Ogallala. Oh, no.
I think you only made it twice, Matt said.
All right, see, at home, you guys can see if you can do any better than that.
See if you can say it 10 times real fast.
Ogallala Aquifer, Ogallala Aquifer, Ogallala.
The Ogallala Aquifer is enormous, but it is left over from water that percolated down from when there was an ice age, a glaciation 20,000 years ago. And the rate at which water comes in is a lot slower than the rate that we're pumping water out. So the water level there has been dropping, which is a big problem. We don't want it to drop all the way because guess how long it would take to fill back up if we emptied it completely?
30 years.
6,000 years.
6,000 years?
Yes.
Oh.
So it's really important whether you live here where the Ogallala Aquifer is or whether you're down in Florida where they have a different aquifer or over here. If you get your water from groundwater, it's really important that you're not pumping it out faster than it's coming in, because if you do, your well will go dry.
But it's not filling up very fast, though, if it could take 6,000 years to refill.
Most aquifers don't fill up very fast, so we've got to be careful.
Water management's a big deal.
It is. Now, next, we are going to talk about caves.
Ooh. So, I love caves.
Caves are pretty cool. And there are certain caves called primary caves where they're formed naturally, but they're not formed by rock dissolving away. Like we mentioned in the introduction, a lava cave is formed by hot lava continuing to move out as the lava around it cools. That's a primary cave. Or you can have a sea cave that's formed by the erosion of waves coming in and out, or sometimes that's called a littoral cave. But the most common type of cave is a solutional cave, and that's formed because carbon dioxide mixed with water makes carbonic acid, and carbonic acid will dissolve limestone. So if you have limestone and you have groundwater coming through it, it will naturally form a cave.
Now that's got to take a long time, right?
It does take a long time. Caves do not form overnight, but they do form, and as they form, something really cool happens. This is from page 93 in the notes. So it all starts with cracks in limestone. And as groundwater comes through, it makes the cracks bigger because it's dissolving the rock and carrying it with it. But once air gets in there, then the cave, instead of growing bigger, the cave starts to fill in with cave formations, stalactites and stalagmites.
Oh, stalactites come from the ceiling, stalagmites on the ground.
That's right. That's right. So here's a fact or fiction for you about the biggest cave.
Oh.
Song Dong Cave in Vietnam, and apologies, I spelled autocorrect, changed dong to doing, and it's spelled wrong. But this cave in Vietnam is so large that you could take an entire New York block from Manhattan and put it inside the cave, and even the skyscrapers would fit inside.
Okay. That cannot be true, because those skyscrapers are enormous. There's no way that one cave could possibly hold them. So I'm going for false.
You're going for false?
Fiction.
Fiction? I'm watching the chat to see. Pickle Obsessed says true. I think you should trust Pickle Obsessed, Math Dad.
Oh, you're just trying to trick me now.
No, this is true. This is true. This has the record currently for being the largest cave we've discovered in the world. It is really old. This cave has been forming for millions of years. And this part right here you see, this is actually a part where the roof of the cave collapsed. This is called a dough line or a sinkhole. And there are full trees, hundreds of feet tall, growing way down here at the bottom of the cave. It's so big, you could actually take a full-size 747 plane and you could fly it for more than 1 kilometer through some of the biggest caverns.
Wow.
And it's more than 5 kilometers long. So caves can be enormous.
I can't imagine that happening naturally.
And the formations that you get when you get stalactites and stalagmites, you can even make your own with Epsom salt. If you have water that has a lot of dissolved things in it, and you can be calcium carbonate or it can be Epsom salt.
What about sugar?
Even sugar, although sugar is really tricky. This little demonstration is a little tricky to get to work. You have to have the water moving, but it has to be moving slowly enough that it will evaporate more here than you have water coming. And you can get tiny little columns or stalactites to form.
And what's causing the water to move?
Gravity, because this point here is slightly lower than the top of the water here and here in the cup.
But how did it get to the center of the string?
Because I got the string wet before I set it up.
So just wicking it up?
Yep, so I got the string wet, and since it's wet, water always tries to flow downhill to the lowest place, and so it's slowly flowing down the string.
So that, I remember this experiment. It was making our counter dirty for
a long time.
Like a full week.
It did take me about a week to grow that lovely column there.
Science mom and her messes.
But I was quite proud of it. All right, so real quick review of what we learned about caves. What's the most common type of cave, Math Dad?
I remember there were a couple types. There was littoral cave, which was the sea.
The
cave,
waves.
The waves.
Mm-hmm. A primary cave is one that formed by like a lava tube. Something natural that did not involve rock dissolving.
Okay, but the one that does involve rock dissolving, that's the most common. And that one had a name.
Solutional Cave.
A solutional cave. Oh, so like a solution, like a chemical solution. Is that where that name comes from?
Yes, exactly.
Because it's dissolving the rock.
There is one final fact or fiction I have for you, and this one relates to caves and has to do with another natural phenomenon that can be a little terrifying at times. So this is a picture of the sinkhole that formed in Guatemala in 2010.
Whoa.
There was a massive tropical rainstorm, and afterwards, this is part of an entire intersection and a big factory building all disappeared down this hole, which was 300 feet deep. And so fact or fiction, this 300-foot deep sinkhole was formed by intense rainfall that caused the ground to erode. Is that true or false?
Okay, because then there would be lots of extra water way down low, and if it washes away the base, then everything would fall. So that's the theory here. That looks like a perfect circle. I mean, they're like a cylindrical hole. I can't believe how round that is. But oh my goodness, is that caused by intense rainfall? Well, doesn't it take a long time for the surface water to get down? So that makes me think that it wasn't the rainfall, the immediate rainfall anyway, that would do that.
Malcolm Burns says false. Dexter says true.
Kai says true. Rebecca, true. Rosalie, true. Oh, they're all saying true. I was about to say false. Oh, I'm going with false. I think it would take too long for the rainwater to get down low enough to cause a sinkhole.
That is correct. This was actually not entirely natural in the way it formed because there were leaking plumbing pipes in this factory building, and those leaking plumbing pipes put a whole lot of water down there, and then that water eroded an enormous cavern. You see the soil and the rock underneath Guatemala City is made from pumice. It erodes very easily, and once this big cavern formed, and all of the leaking sewer pipes, then this weak spot and the weight of the building caused a perfectly circular opening to form, and it all fell through.
Oh, man.
And I did see a couple people asking, was everyone okay? There was one missing person. Fortunately, it was a factory building and it happened at night, and so people weren't at work. There was one missing person where they're not sure.
That was fortunate, though.
Yes.
Because factories could be really full of workers, and that could have been really bad during the daytime.
If our buildings are on top of a rock that erodes really easily, it turns out that leaking pipes are really hazardous. Because if you have a leaking pipe, that can cause a lot of erosion. And just normally, you do have an effect called a sinkhole. Sinkholes form when you have caves underground. And so you have to have some sort of carbonate rock or something where you can have caves form naturally. And once you have a cave form, if the layer that is over top of it is mostly sandy, that sand can start to drift down in. And as it drifts down in and fills up the cave, you end up with a depression. That's a sinkhole. And this type of sinkhole happens slowly. It's going to take a long time to form. It's not going to swallow up buildings all of a sudden. And this is the more common type of sinkhole. But if you have a mostly clay layer that is not going to drain down in quite as well, and if you have a cave form, and then as this is forming,
you got a hole, a big gap forming there.
If you get a really big cave forming and the layer on top is thin, then all of a sudden it can collapse. And that cover collapse sinkhole, that can be pretty dangerous and just all of a sudden.
You had a sinkhole by your house when you were a kid, right?
I did, a couple sinkholes. And you know what that means? That means that there is some type of limestone or other rock underneath. And it might be just a few feet underneath, or it might be hundreds of feet underneath. But for sure, there are caves underneath where those sinkholes are. And those caves might now be filled up with dirt because the sinkhole formed, or they might still be there. It makes me kind of wish that I had X-ray vision and I could just look down and see what's going on.
That would be way cool.
It would be very cool. Now, if you are ready to test your knowledge, head to itempool.com/sciencemom/live. And the first question we're going to ask, there are no points attached to it. We just want to know, do you know? All right, so it's not the first question.
That's the last question.
Okay, so the last question. Well, I want to give him a heads up anyway. Do you know where your drinking water comes from? We're going to ask.
Yeah, does it come from a well on your land, or does it come from a nearby lake or reservoir? Or are you getting water from an aquifer? You might even be able to ask your parents or somebody nearby real quick, because we are going to ask that question as our last question of the day.
And you might know real quick, I have a private well. We own our own well. We live out in the rural land. Or you might know, well, we just get water from the city. If you get water from the city, you can Google real quick. Does that city water come from a river, a lake, or groundwater?
Okay, and I'm seeing already people in the chat are like, I get mine from the fridge. Like, yeah, where does your fridge get the water? That's what we're asking.
And if you only drink bottled water, you should stop, because tap water, if you want to filter your water, you can filter it from the tap. But it's much better to not drink bottled water in plastic disposable water containers.
Well, okay, with the exceptions of, there are people who don't have safe drinking water. And in that case...
thank you, Math Dad.
Go ahead and drink the bottled water. But most of us, tap water or other sources are just going to be way more environmentally friendly.
All right. As Math Dad is pulling up our quiz, we do have... You can do it, Math Dad.
Maybe. There we go.
There we go. We do have birthdays. I want to wish a super happy birthday. Gotta find the right date. Here we go. To Owen, who turns 11 today. Happy birthday, Owen.
Good job, Owen.
And then also we have 2 summer birthdays. Miriam and Sarah both have birthdays in the summer. But their parents sent me an email and said, we figured out on the lunar calendar that Miriam turns 11 last week and Sarah turned 7 yesterday. So happy early lunar birthdays to Miriam and Sarah.
Nicely done. Oh, I hadn't thought about that. You can get extra birthdays in a year if you figure out multiple ways to celebrate it.
You definitely can.
All right. We're going to start off with our first question of what is the most common type of cave? Is it a solutional cave, a primary cave, a littoral cave, or an erosional cave?
And as a bonus question, I'm curious if anybody knows what type of bedrock is most likely to have cave. So if you dig down below the soil, you'll hit like the more solid rock, and bedrock can be made out of different things. It could be sandstone, it could be volcanic, igneous rock, it could be limestone, it could be like a carbonate rock, sedimentary rock. What type is more likely to have caves? So put that in the chat or in the comments of the video if you know. That's our bonus question. And let's.
Did that question not make the cut? I'm trying to remember even. All right. So answer is
Solutional cave, and that is 100% correct.
So real quick review of what those different types of caves were. Solutional cave was when we dissolved limestone.
And Sam says limestone bedrock is the most common to have caves, and that is correct.
Because the solutional caves are the limestone, right? Yeah.
There are other types of rock where you can also get caves from, a carbonate rock that's sedimentary can form caves, but limestone is the most common.
A primary cave, something like a lava tube, something that was formed maybe all at once. And then a littoral cave was a sea cave.
Yep.
What if it was caused by wind? Is that also a littoral cave? If it was
there are different types of erosional cave from like rivers or wind. Those are not quite as common. Right. So nicely done. And I'm seeing so many people, shout out to Amelia and several others who put limestone in the chat.
Well done. All right. Question number 2. A water table is an area where water saturates the spaces between sediments, the boundary between saturated and unsaturated rock, an area where water does not saturate the spaces between sediments, or is it dining furniture made from ice?
And really fast, I just heard from our moderators, we have 2 more birthday shout outs. Happy birthday to Gemma today, and happy birthday to Jennifer, who has a birthday tomorrow.
Hey.
Woo!
Everybody's getting older.
Everyone is getting older.
At our house, we got a rule, no growing. And my kids just don't follow that rule.
That's one of Math Dad's favorite jokes. And our kids think it's really funny. Every time they get taller, look at me, Dad, I'm growing.
They're rebels through and through. All right, I'm gonna finish and reveal the answer. It's the boundary between the saturated and unsaturated rock. Oh, I thought we'd get them.
Nice job.
Because 2 of the questions were so similar, and usually with multiple choice, if there are 2 similar questions, one of them's right, and they didn't fall for it.
You got to work harder to stump the unbeatable sides, kids, Math Dad.
Yep. So the water table is that layer where
the boundary.
The boundary layer. The boundary. So below that water table, you're going to have saturated rock, full of water.
I did see several people asking what cave is on the video thumbnail. I don't remember off the top of my head, but I'll look it up and I'll put it in the video description later.
All right. Question 3. How many years would it take for rainwater to refill the Ogallala Aquifer?
And then Eleanor had a great question. Can there be life in caves? Like, are there animals that can live in caves? The answer is yes, although most of them are very small and most of them are blind because the natural environment of a cave is entirely dark. So there's no need to see. There's a tiny little pseudo scorpion, and scorpion sounds kind of scary, but this is really just teeny tiny and doesn't look too much like a scorpion that lives in certain caves around here in Nevada. And there are some really cool glowworms that live in caves in South America.
Oh, that is cool. I just think of bats when I think of caves.
Oh, bats like caves too.
Yep.
That is true.
All right. And we're going to reveal the answer. 6,000 years. Oh, they must have been listening, Science Mom. I don't think they would have gotten that one without you telling them. So 6,000 years to refill an aquifer.
Some aquifers take even longer to refill.
Oh, wow. And I mean, so if we take all that water out, we're left without a water source in some places. Water management is going to be a huge topic of debate and contention, and just something we have to do better at in the future because we're going to make life hard on ourselves. We need water.
We do not want to run out of our groundwater.
All right. What portion of the U.S. population relies on groundwater for their drinking water supply. And worldwide, the situation's going to vary from country to country. We didn't have that data, so we're just focusing on the United States. But yeah, it'd be interesting if you're not in the U.S. Look up what your country, where they get their water. Make sure that you're aware of that. Ooh, man, 46 votes for one answer. Cal,
what do you think, Science Puppy?
I haven't stumped them yet.
Let's go ahead and finish and reveal. 38%, according to the U.S. Geological Survey, 38% of us in the U.S. rely on groundwater for our water. So it's really important to make sure that the water is safe to drink and
that we don't
pump it out faster than it's going in. Now, groundwater, you can kind of think of it as being naturally filtered by the ground. Oh, I forgot about. Oh no, Matt, that I spoiled this question.
Yeah, that's what I thought. But okay, keep going. We haven't asked. What are you saying?
Oh, okay. Sorry, apologies. I forgot what I was saying. Let's just go ahead and ask this question.
I derailed it. All right. Which type of bedrock is most likely to have sinkholes?
And quick, Mimi Grace is a really good listener. She said I said 39% and it was 38. Those are both close enough.
But rounded one way or the other.
Yep. But kudos to you for noticing that difference.
They're paying attention, Science Mom. They will correct you.
Now, this one, I know that when we asked it informally in the chat, a lot of people put down the right answer. Let's go ahead and finish and reveal. What type of bedrock most likely to have sinkholes? Limestone.
Limestone.
If you have sand that is not cemented together very well, like hasn't been made into true sandstone, like the pumice and the ash deposits in Guatemala City, that also can form a lot of sinkholes. So there are different types, but limestone is one of the most common.
All right. And then here, there's no right or wrong answer, but we want to know, where does your drinking water come from? So something of a survey. Do you get your drinking water from a private well, a public water supply, from groundwater, a public water supply from surface water,
lakes and rivers, or do you not know? That's a perfectly okay answer too. If you're like, well, I could guess, but I'm just not sure.
Yeah, don't guess. If you don't know, just say I'm not sure.
And then look it up later.
Absolutely. So this is an invitation for you to learn more about it. I've got to say, as a kid, I wasn't sure where we were getting our water from. And yeah, it's so easy to take these things for granted, but yeah, scientists need to know these types of things. So we're all on our way to being science experts here. And yeah, we've got to ask ourselves these questions and not take them for granted.
Where I grew up, the water came from a well, and I know that the well was really deep. When they first started drilling, they expected to have to drill just this deep, and I think they ended up going down like 400 feet deeper than they thought, which ended up being expensive, and I know there were some people who were quite disappointed.
All right. And so a lot of people are not sure, but public water supply from surface water, so you have maybe a reservoir nearby,
was 35, and then A from a private well, and B from groundwater. Interesting.
So quite the mix.
If you live really in a rural area, private wells tend to be more common just because there's not the infrastructure to pipe water from a public water system. And then if you live in a city, almost for sure, your water is going to be from the public water source. But whether it's from surface water or groundwater just really depends on the city. And some places even have a mixture of different sources.
I noticed Finn was suggesting that in Minecraft they should totally add sinkholes as a thing. That would be cool.
Sinkholes are fascinating and also a little bit scary.
Oh, got some good questions coming in, and some really fun to see who knows more than I did when I was a kid about the water supply and where things are going. But one of the big goals of this course is just for us to be more environmentally aware. So we said, if we can, don't use bottled water. If your drinking water from the tap is going to suffice. Mm-hmm. Yeah, I mean, we just need to be conservation minded. We need to be thinking about the future, because decisions that we make today are going to affect us and future generations.
There was one question from Quinn, I want to answer really quick. How many kinds of aquifers are in the United States? It turns out there are a lot of different kinds. And not all aquifers have water that we can drink. Because do you remember there's a certain type of rock called rock salt? And so even if you're inland and you're far away from the ocean, if there's a layer of rock salt from like an ancient ocean that was deposited, and then the groundwater goes through the rock salt, you could actually have an aquifer that is salty. Yes.
Oh, man.
And if the aquifer is salty, then we can't drink it. And if the aquifer is next to some hydrothermal activity where you have volcanic gases coming up, your aquifer might have a lot of hydrogen sulfide in it. And do you want to drink water with hydrogen sulfide?
It doesn't sound very good.
No, you don't. So just because water is in the ground, that does not mean it is safe to drink. You always want to get your water tested and make sure it is safe. But most groundwater has filtered through gravel and sand and other things and gone through enough rock layers that it ends up being pretty clean.
Did it distract them from their dance request, Science Mom?
No, you didn't. And did we manage to edit that video with a new dance?
No.
All right. So I'm going to say that it's going to be the ballet, which is not quite ballet.
It's beautiful. What are you talking about?
Here's the ballet dance. Where Math Dad got dizzy just spinning around a couple times.
I can't do that anymore.
And don't worry, for on our last one, we'll show all of the dances. I saw Sam and several others requesting the Russian squat dance. We'll show them all at the end, and we will film some more soon. Work hard, grow smart, you guys. Thanks for joining us, and we will see you on Wednesday to talk about rivers.